Hello, I am Lukman Hakeem and I just started my PhD from SKK University under Professor Kim Jion in GMP lab, and in this short video I would like to introduce you about my research topic, which is basically production of jet fuel from biomass. Okay, so let's start with the contents. First of all, I would like to go through the background, and then I would like to introduce you about this topic, and then I will go through lignin to fuel conversion. Lignin is basically component of biomass, and then finally we will go through the hydrodeoxygenation of lignin, which is basically the typical reaction for lignin to fuel conversion. Okay, so let's start with the background. So we all are quite familiar with the global warming term, which is basically increased temperature of the earth due to the increased concentration of global warming gases, one of which is CO2. We are all quite familiar with this. These gases basically create a sphere around the earth, which basically resist solar rays uh, after striking the earth from coming back. So there is another reason for this, which is regarding the depletion of fossil fuels. We all know that we are using the fossil fuels in quite large quantities, um, which is basically drastically decreasing the amount of fossil fuels that are available to the humanity. So these two are the major factors due to which there is a lot of research going on regarding the alternatives. So we have biomass waste, which is approximately 170 billion metric tons per annum, which is quite high amount. So we can use this biomass to convert it into the fuel which we can utilize. Previously, there was a lot of criticism on this, that scientists will be using food stuff and other things for converting it into the fuel. But we are here talking about the biomass that is available in terms of forest waste, like leaves and woods, something like that. And another thing is that we can utilize CO2 to produce the chemicals and fuel, these things, which will ultimately result in reducing the global warming. And there is another thing, that is solar energy. We can utilize it for electricity production and for other tasks like chemical production and these things, using the solar energy. Okay, so let's start with the introduction. So biomass basically consists of three components: cellulose, hemicellulose, and lignin, that are in varying proportion, which depends basically on source. From one source to another source, amount of these three components can vary. So among these three, lignin is a better option for jet fuel, and reason is that this contains a high hydrogen to carbon ratio and lower oxygen to carbon ratio, and it has a higher density compared to the other two, cellulose and hemicellulose. Okay, so lignin is basically 3D amorphous polymeric biopolymer, which has large branching and it is hydrophobic. So building blocks of lignin are basically p-coumaryl, coniferyl alcohol, and cinepial alcohol. And you can see here that there are majorly three components, like hemicellulose, cellulose, and lignin. Okay, so now let's move towards the lignin to fuel conversion. Okay, so Uh, there are some problems which are basically associated with the liquid fuel production from the lignin, and these problems are like high acidity, which may result in corrosion, and it has low uh, heating value due to the presence of water and oxygen containing groups, and it has poor volatility. It has poor thermal and chemical stability due to the oxygen containing groups. It has high polarity, which makes it immiscible in conventional fuels. For example, if we like to mix certain portion of biofuel to the conventional fuels to use it as a mixture, so it creates a problem due to high polarity, and it has high viscosity. So, from these problems, we can understand that oxygen is basically a major factor, which is basically existing in the development of liquid fuels from lignin. So, what we'll be doing, we'll be discussing the hydrodeoxygenation of lignin, which basically removes the oxygen containing compounds from lignin, so that we can avoid these problems. So various researchers and government agencies predicted biomass use of 20% transportation fuels and 25% for chemicals by 2030. So what is hydrodeoxygenation of lignin? So it is basically removal of oxygen containing groups from lignin. So we basically use the hydrogen gas under the presence of different catalysts, like people have used nickel, ruthenium, palladium, platinum, and various others in different combinations on various boards like silica, CNX, carbon, under different temperature conditions like 250 to 400 degrees Celsius, and under varying pressures to perform the hydrodeoxygenation of the lignin. Okay, so but problems are again there, like lignin is basically a polymer which basically further polymerizes on catalysts uh, under some intermediates which basically occupy the active sites of the catalyst, which makes it deactivated, and we can't use it again and again. So in order to negate these problems, various methods have been proposed in literature, like we can depolymerize lignin, and then we can separate the monomers from dimers and oligomers. After the separation of monomers, we can use these monomers for hydrodeoxygenation reaction, and in this way we can avoid the catalyst deactivation, and in this way we can also increase the production efficiency, which is basically amount of hydrocarbon being produced from lignin monomers under a certain time and amount of catalyst. Okay, so let me show you here the process. Like if we have one step process, lignin will be subjected to the catalyst under reaction conditions like temperature and pressure. So this is basically one step, and we will obtain the fuels. And there is another approach that is basically three-step process. Under this three-step process, lignin is basically converted, depolymerized to monomers, dimers, and oligomers. In the second step, we basically perform the purification, where we basically separate the monomers from the other dimers and oligomers, and then these monomers are basically used in the reaction HDO, that is hydrodeoxygenation reaction, to produce fuels. Okay, so I think that is all from my side regarding the introduction of my research field. Thank you for your attention.